Welcome to the deep dive. Today we're really getting into the world of programming languages, specifically looking ahead sort of into 2025.
Yeah, and we've pulled together quite a bit of material for this, articles, research, forum discussions. It covers what languages recruiters are chasing, how you might think about choosing one if you're starting out or maybe switching gears.
And that big question too, right? Can you really future-proof your tech skills? Things change so fast.
Exactly. So that's kind of the mission for this deep dive.
We want to unpack what makes a language popular right now, offer some, practical ways to think about picking one that fits your goals.
And tackle that whole future-proofing idea. Is it real? Or should we be aiming for something else?
Okay, let's jump right in then.
Sounds good.
All right, so thinking about that mission, where do the sources say the action is? Like right now in 2025, what's actually in demand?
Well, it depends a bit on how you measure it. You've got job postings, usage stats from places like GitHub, developer surveys, recruiter feedback, even search trends.
Different angles. But are there some consistent winners?
Definitely. If you look at what recruiters are actively looking for, one source, iTransition, has Python way out front. Something like 45.7% of recruiters want Python skills.
Okay, nearly half.
But JavaScript is right up there, 41.5%, and Java is close behind at 39.5%. So those three are, clearly hot commodities in the job market based on that data.
Okay, so that's recruiter demand. What about like overall usage? How much are people actually using these languages day to day?
Right, and that's where Python's story gets, well, even more interesting. iTransition highlights it's now #1 on the TIOBE index.
Which is a big deal, right? That's a major benchmark.
It is. It measures popularity based on searches, community activity, that sort of thing. PyCon's got a 23.28% share there, and, maybe even bigger news, it's finally overtaken JavaScript as the most used language on GitHub. First time in a decade.
Wow, okay. Pulled ahead on GitHub. That is significant.
Yeah. But the others are still major players. C++ is #2 on TIOBE, about 10.29%. Java, the enterprise favorite, is still incredibly solid. Always in the TIOBE top 5 since, 2000, and top 3 on RedMonk's index.
And RedMonk looks at GitHub and Stack Overflow usage.
Exactly. C# is also in RedMonk's top 5, though interestingly, iTransition notes it slipped to 5th on TIOBE in 2025. It was actually #1 back in 2023.
Huh. So still strong, but maybe a slight dip in overall buzz compared to a couple years ago. It shows you need to look at multiple sources. I think CodePlatoon had a different #1 based just in job ads.
Yeah, they did. Their data, looking purely at job postings, actually put C# first, then Python second, JavaScript third.
Okay, so the exact order might shuffle a bit depending on the metric, but it's largely the same group dominating: Python, JavaScript, Java, C#, C++, Rust.
Pretty much, those are the core ones you see again and again.
Yeah, let's get to the part everyone's always curious about, the money. How are the salaries looking for these top languages?
Hey, yeah. The sources have quite a bit of salary data pulled from different places. Indeed, Glassdoor, ZipRecruiter, even specialist sites like Ruby on Remote, usually U.S. averages from, late 2024, early 2025.
But the numbers can vary a lot, right?
Yeah.
Depending on the source of the job.
Absolutely. Location, years of experience, the specific company, the exact role, it all makes a huge difference. But the overall trend is clear. These high-demand languages command competitive salaries.
Give us some ballpark figures from the data.
Sure. So iTransition, using Indeed data from February 2025, shows Python averaging around 124K, or JavaScript, about 114K on Indeed for the same time.
Okay.
But then look at Ruby on Remote's data. They have JavaScript much higher, like 146K average. Same for Java. Indeed showed maybe 90K, but Ruby on Remote puts it around 153K.
Whoa, that's a massive difference for Java. Why such a big gap?
It likely reflects different types of roles being aggregated, maybe more senior or specialized positions on Ruby on Remote. It just underscores that these are averages. Averages can hide a lot.
Makes sense. So treat specific numbers with caution, but look at the overall picture.
Exactly. And the picture shows C# salaries ranging from maybe $99 on Indeed up to 163K on Ruby on Remote. C++ looks consistently strong, like 128K average on Indeed.
And some others were mentioned with high numbers too.
Yeah, languages like Go and Swift popped up with really high averages on Ruby on Remote, hitting like 173K and 171K respectively. Rust, TypeScript, they also consistently showed averages well north of $100 in various sources.
Okay, so the takeaway isn't learn X to make exactly Y dollars.
Yeah.
But more that mastering any of these top-tier languages generally puts you in a good position for a well-compensated career.
That's it. The demand drives the compensation.
So stepping back a bit, why these languages? What is it about Python, JavaScript, Java, C#, C++ that keeps them so dominant? What problems do they solve?
It really boils down to their strengths and where they fit in the tech ecosystem right now. They each have niches where they excel.
Okay, let's take Python first, given its recent surge. You mentioned AI.
Yeah, AI and machine learning are massive drivers. Python's simplicity, its readability, and especially its huge collection of libraries for data science and ML make it the default choice there. Plus, it's great for web backend stuff and automation scripts. Generative AI has just poured fuel on that fire.
Makes sense? And JavaScript. Still the king of the web, even if Python passed it on GitHub.
Oh, absolutely essential. JavaScript is the language of the web browser. It handles all the interactive stuff on the front end. And with Node.js, it's a major player on the back end, too. Building complex web apps, single-page applications, its ecosystem is really mature.
And Java, the old reliable.
Yeah, Java's strengths are its robustness, scalability, and security. That makes it perfect for big, complex enterprise systems where things just have to work reliably. It's also the main language for native Android apps, and you see it in big data and the Internet of Things as well.
C# seems really tied to the Microsoft world.
It is, largely. It integrates super tightly with Microsoft's .NET platform, so building Windows apps, enterprise software in that environment, that's its bread and butter. But it's also huge in game development, especially with the Unity engine.
Right.
And you're seeing it more for cross-platform mobile apps, too.
Okay. And C++, the Uni daemon. The B daemon.
Basically, yeah. Performance, efficiency, low-level control, that's C++. Essential for operating systems, embedded software, think the code running inside your car or appliances, game engines themselves, high-frequency trading, real-time systems.
Anywhere that raw speed matters.
Exactly. The iTransition source actually singled it out as the most popular language for self-driving car engineering. That tells you something.
Definitely. And quickly, what about Go and Rust? They had those high salary numbers.
Right. Go, or Golang, came out of Google. It's known for being pretty simple to write, great built-in support for doing many things at once concurrency, and it's fast. So popular for web services, cloud infrastructure, that kind of thing.
And Rust seems to get a lot of developer love.
It does. Rust's big selling point is memory safety without needing a garbage collector, which is a mechanism many languages use to manage memory automatically, but can sometimes impact performance. So you get high performance and safety. It's used in systems programming, embedded, web infrastructure, even blockchain. One source mentioned it's consistently voted the most admired language by developers in surveys.
High praise. We should probably also give a nod to HTML and SQL, right? Not strictly programming languages in the same way, but they always show up.
Good point. Absolutely foundational. HTML provides the actual structure and content for web pages. You can't build a website without it. iTransition noted it's like the second most popular thing for beginners to learn.
Makes sense. Build the simple web page first.
And SQL, structured query language. That's how you talk to databases, how you store, retrieve, manage data. Ranked super high among professional developers for popularity and desirability. In modern software, you're always dealing with data, so SQL is just crucial.
Okay, so that paints a really clear picture of the landscape. But now, maybe the million-dollar question for a lot of listeners. If I'm starting out or maybe thinking of switching focus, how on earth do I choose a language?
Yeah, it can feel overwhelming. Interestingly, the sources offer some maybe slightly counterintuitive advice here.
Oh, how so?
Well, there's this perspective from a professional developer on Reddit who argues pretty strongly that ease of learning should actually be the last thing you consider when picking your first language.
Wait, last? That feels backward. Isn't easy good when you're starting?
You'd think so, but their argument is if your goal is a career, choosing only based on ease can be a trap. If the easy language doesn't actually lead to the jobs you want, or if it doesn't teach you core concepts that transfer well, or if its job market is, like, super volatile.
You might learn it fast but hit a wall.
Exactly. You might spend time getting good at something that doesn't actually advance your career goals. Time you could have spent on something more strategic, even if it was a bit harder initially.
That's a really practical, if slightly tough, perspective. So, if ease is last, what should be the priorities, according to this developer? They listed 5 factors.
Right. Number 1, top of the list, employability. Simple question. Are there jobs using this language where you want to work? In your city? At the companies you're interested in? Don't just learn something cool, learn something that gets you hired.
Obvious, but easily overlooked.
Okay.
Number 2.
Transferability. Does learning this language teach you the fundamental ideas of programming? Variables, loops, functions, data structures, how to think algorithmically? Does it build a foundation that makes picking up your next language easier? Some languages are better at teaching those core concepts than others.
Yeah, to build that mental toolkit. Number 3 was versatility, but with a catch.
Yeah, versatility specifically in the context of paying jobs. Is this language actually the standard tool for the kind of work you want to do professionally? The example given was game development. Sure, you can make a simple game in Python or JavaScript.
But if you want to work at a major game studio,
You probably need C++ or C Sharp because that's what they use with engines like Unreal or Unity. So it's not just can it do the task, but is it the professional standard for that task?
crucial distinction. Okay, number 4.
Stability. How likely are your skills in this language and its associated tools and frameworks to remain relevant? Or is it an area like, say, front-end web development has sometimes been, where popular frameworks seem to rise and fall really quickly, forcing you to constantly relearn?
Right, like the Reddit post mentioned jQuery and AngularJS kind of fading away.
Exactly. So you've got employability, transferability, versatility, stability. Then at the bottom of the list.
Ease of learning.
Right, it matters, sure. Being less frustrated helps you stick with it. But according to this view, it should be the tiebreaker, not the primary driver, if your goal is a career.
What's interesting is even sources like Zero to Mastery, which do recommend Python or JavaScript for beginners, partly because they're easier.
They still kind of hit those other points too, right?
Exactly. They recommend Python or JS, citing ease, yes, and that they're fun, but they also stress the high demand, the good salaries, the employability.
And their versatility. ZTM points out how learning one of those opens up so many different career paths.
Right. Python leads into cybersecurity, ML, AI, data science, automation. JavaScript is the gateway to front-end, back-end, full-stack web, mobile apps via things like React Native.
So Zero to Mastery isn't just saying pick these because they're easy. They're saying pick these because they're easy and strategic. They hit those employability and versatility marks hard.
And their advice on choosing between Python and JS basically comes down to that versatility point again. Are you more drawn to AI data? Maybe lean Python. More interested in websites and apps? Probably JavaScript.
Makes sense. And another source, Geeks for Geeks, talking about learning any language, also hammered home choosing based on your data science, web dev, competitive programming, and then focusing on building a really solid understanding of the fundamentals.
Variables, conditions, loops, functions.
Yeah, and eventually data structures, algorithms, maybe object-oriented concepts, the underlying principles that apply everywhere.
Which just reinforces that core idea.
Yeah,
Learn the concepts, not just the syntax.
exactly. Learn to think like a programmer.
Okay, which leads us perfectly into the really big question, I suppose.
Yeah.
Can you pick a language today that guarantees you'll be set years from now? Is future-proofing even possible?
Yeah, the consensus, especially from that Reddit discussion among professionals, seems to be a pretty clear no. The idea of finding one magical language that will just stay dominant and relevant forever, probably not realistic.
So all that stressing about, did I pick the right one for the long haul, might be misplaced energy.
According to these sources, yeah, largely. The key takeaway, repeated over and over, is that your ability to learn and adapt is the real future-proofing skill.
Not the language itself, but your capacity to pick up the next language.
Exactly, because the core programming concepts, how loops work, how you structure data, conditional logic, those are transferable. You just express them with slightly different words, different syntax, in a new language. The fundamental thinking stays the same.
Someone on Reddit used COBOL as an example, right?
Yeah.
A language from the 50s.
Yeah, definitely not future-proof in terms of being cutting-edge tech. But there are still well-paying COBOL jobs because massive critical systems in banking and government were built with it, and they still need maintaining. The need exists, so the job exists, even if the tech is ancient.
And even today's popular languages don't stand still.
Not at all. Look at how much C++ has evolved,
Yep.
or JavaScript, or the huge changes moving from Python 2 to Python 3. Languages have to evolve to stay relevant. A language that never changes is probably a language that's dying.
Stack Overflow had a slightly different take, talking about change-proofing instead of future-proofing.
Right.
What was that about?
Right. Their angle wasn't about making your system immune to future changes, but designing it in a way that makes future changes easier to implement when they inevitably happen.
Okay, that sounds sensible. But they immediately brought up a conflict with a classic software principle, YAGNI.
You ain't gonna need it. Yeah. It's this idea that you shouldn't build stuff based on speculation about what you might need someday, because often you guess wrong or the need never materializes, and you've just added complexity for nothing.
So how does that conflict with change proofing?
Well, Stack Overflow argues that if you go too far trying to make your code super flexible to handle every conceivable future change, you risk violating YAGI. You end up with layers of abstraction, complex designs, basically technical debt built to handle changes that might never come.
Ah, okay, so it's a balancing act. Design for likely change, but don't over-engineer for every possible change.
That seems to be the idea. They talked about using techniques like modularization, breaking code into small, independent parts, and abstraction hiding implementation details behind simpler interfaces. These can make certain kinds of changes less painful.
But they stressed it depends heavily on the type of change you're anticipating.
Yes, this was a key point. They were very direct about changing your fundamental technology stack, like planning to swap out your main programming language or your core database down the road.
They said don't bother trying to plan for that.
Pretty much. They called it almost impossible to build language agnostically in a practical sense and said switching core databases is actually pretty rare. Trying to design your whole system up front to easily swap, say, Python for Java or PostgreSQL for MySQL later, they labeled that flagrant yayoginai.
Flagrant YAGI, okay. Strong words, so don't architect for a total language transplant.
Generally, no, according to that article, but they contrasted that sharply with changes involving integrations.
Like connecting to outside services.
Exactly. Payment gateways, analytics tools, third-party APIs. There, they said, using abstraction and modularity, maybe building a wrapper around the third-party code is often a really good strategy. It makes it much easier to swap out one payment provider for another later, for instance, without having to rewrite huge chunks of your own application logic.
That makes total sense. You're way more likely to change a third-party service than your entire core language.
Right. So the overarching message from all these different sources, Reddit, Geeks for Geeks, Stack Overflow, really converges. Stop chasing the myth of the future-proof language.
And instead,
Focus on building a really deep understanding of programming fundamentals. Get hands-on experience by building things, making mistakes, learning from them, and consciously cultivate that skill of learning how to pick up new languages, new frameworks, new tools as the landscape inevitably shifts.
your ability to learn is the skill that endures.
That's the core insight. Technologies change, problem solving and adaptability are timeless.
Okay, so let's bring this all back home. What does this mean for you, the listener, especially if you're in the process of learning or deciding what to learn next?
Well, first, just understanding that demand landscape we talked about is useful. It tells you where the opportunities are clustered right now. You see the impact of trends like AI boosting Python, for example.
And thinking about those 5 factors, employability, transferability, versatility, stability, then ease helps you make a choice that's less about immediate comfort and more about long-term strategy, aligning your learning with your actual goals.
Definitely. And maybe the most freeing insight is letting go of that future-proof anxiety. Knowing that no language is forever takes the pressure off finding the single perfect choice.
Right. So instead of agonizing over picking the absolute best language for the next 20 years, you can channel that energy into really mastering the core concepts
Building stuff, getting practical experience.
and just getting good at the process of learning itself, because that's the skill that will carry you through future changes.
Exactly, those foundational problem-solving abilities and your adaptabilities, those are your real long-term assets in this field.
Well, that wraps up our deep dive into programming languages for 2025. We've looked at what's hot, how to maybe think about choosing a path, and debunked the myth of the future-proof language, landing instead on adaptability and fundamentals.
It's definitely a field that keeps you on your toes.
It really does. And maybe a final thought for you to chew on. Given how fast things are changing, and especially with AI tools becoming so integrated, Code Platoon says 62% of developers already use them, seeing them more as tools than threats. Maybe the most crucial skill moving forward isn't just mastering language syntax, but mastering fundamental problem solving, critical thinking, and the ability to effectively integrate these powerful new tools into your workflow, something to think about as you continue your journey.